I'm going to explain the concept of logistic regression for you using a practical example from the Finance ResearchGate website.
So I'll proceed by selecting a single frequency, considering that both the x and y variables share this identical frequency. Specifically, we'll choose the annual frequency and then define our start period as the year 2000, extending all the way through to the end of 2024. Once that's set, we'll apply this defined period, and subsequently, we'll apply this particular case to our analysis. Our primary objective here is to accurately predict whether the firm in question is distributing dividends or not during any particular year.
So the x variables that have been selected, they are profitability.
We need to evaluate the company's size and its book-to-market valuation.
Concerning the y variable, we do not have a binary variable present here. Instead, we possess the continuous version of it, which is known as the dividend yield, the specific amount of dividend yield.
Then, as we continue scrolling down, it will be necessary to lag the x variables
By adjusting just one single period, and then we'll be able to quickly examine and determine if there are any significant outliers present. It's highly probable that we will find some, given the considerably large sample size we're beginning with. Therefore, we're going to proceed by increasing it just this one time. We need to examine the x variables as well as the y variables at a 1% significance level, and then we can create them. Alright, so when it comes to setting up our binary variable, there are actually two distinct methods available to us. The first method involves navigating to the dedicated dummy variable section, and within that area, we can then proceed to create all of our necessary dummy variables, and once those are established, we'll be able to easily select our primary y variable, and then we can ensure that the value is always above 0. Therefore, I strongly advise against using the precise numerical value in this particular instance, as there's a significant risk that the system might interpret any absent data points as having a value of 0, and consequently, the final result or the overall outcome would not be truly accurate or reliable. My recommendation would be to select a very small value, for instance something that is practically 0, and then you would incorporate a dummy variable. At this point, you are presented with two distinct options. One approach is to consider any missing data points as having a value of 0. Therefore, if there happens to be an absence of reporting for the dividend yield, you have the option to treat that specific instance as 0. So let's proceed with that particular strategy.
And then we'll proceed to add the dummy.
So what we're observing here is the final outcome, which clearly indicates that for the vast majority of our firm year observations, we simply do not have any dividends being reported in the data. Consequently, this implies that the dividend yield for these specific observations is, in all practical terms, effectively 0. It's quite striking that we've only managed to identify approximately 20% of all firm year observations that are actually paying dividends. Alright, let's navigate down to locate the logistic regression model, which is typically found within the advanced regression section. For our analysis, we'll select the binary dependent variable, as that's precisely what we're dealing with in this scenario. To clarify, a binary outcome signifies either a 0, indicating the company did not distribute dividends, or a 1, meaning it successfully paid dividends throughout that specific time frame. And finally, our regressors, or independent variables, will be the chosen x factors that we've identified for this modal. After we've made our final choices, we'll be completely ready to proceed with everything. The only remaining task is to select the most suitable logistic option. And so here we have our prediction. It makes sense that larger companies possess a greater capacity to distribute dividends. This is precisely why the coefficient shows a positive value. Well, it's observed that more profitable firms tend to pay out higher dividends. And when we look at their book-to-market ratios, these companies often exhibit higher values, which means we're dealing with what are known as value firms. Consequently, these types of businesses don't typically require a large amount of retained earnings. In order to finance their potential growth opportunities, companies often find themselves in a position where they have fewer new projects to invest in. Consequently, they are more inclined to distribute their earnings to shareholders by paying out higher dividends. So these coefficients reflect the likelihood. So with larger size, we have a higher likelihood of a firm paying dividends. With larger profitability, we have a higher likelihood of a firm paying dividends. So we're dealing here with probabilities. Here we can delve into more detailed statistical analysis. For instance, we can examine the direct comparison between the actual observed value and its corresponding predicted probability. I've noticed that these values consistently range between 0 and 1, so we have both the true actual outcome and the predicted likelihood. What's particularly interesting is that they appear quite close and generally trend in the same direction. So, If you make a prediction of a substantially higher numerical value, which would then clearly signify a considerably increased probability that a particular company will be distributing its dividends within a given fiscal period, then this outcome would be appropriately represented and integrated into the analytical framework of the model. We are in a position to provide a much more detailed and descriptive explanation concerning the nature of our prediction. For instance, if we consider the specific example, the total number of firm year observations that we accurately classified as positive, meaning those companies actively paying out dividends, proved to be entirely correct. While some false positives do exist within our data, their occurrence is significantly less frequent compared to the true positives, which is certainly a very encouraging sign for our analysis. And we also managed to truly classify those non-paying dividends, 26,200, much more than the false negative. So we encounter two types of errors in our analysis, false positives and false negatives. Focusing on the false negatives, these represent situations where we mistakenly categorize certain firms. Specifically, we incorrectly identified them as not paying dividends. However, upon closer examination, it was revealed that these very firms were in fact distributing dividends to their shareholders. This metric is substantially greater than the observed false positive rate, which clearly indicates a pronounced tendency for our model to classify a firm as a non-paying entity. This outcome is in fact entirely expected, primarily because the original data sample from which our model was trained inherently contains a significantly larger number of non-paying firms.
So the accuracy we're seeing here is already quite good, and if we add a few more X variables into the model, the statistics here would likely show a significant improvement.
As you can see in the chart displayed above, and this particular chart, as we discussed, will once again effectively illustrate the direct comparison between the probability that we predicted and the actual real-world outcome. And naturally, as we would expect, these two sets of values are moving in precisely the same general direction. So that concludes our detailed discussion on the topic of logistic regression. We appreciate you taking the time to watch this presentation.